Welcome everyone to our 10-part breakdown of Cornell's fantastic lectures on financial machine learning. I'm your quant expert and I'll be guiding you through the concepts. And I'm the novice investor. My job is to ask the questions and make sure this all makes sense for those of us trading in the real world. Let's get into it.
We're starting with a pretty explosive quote directly from the professor. As a result, most econometric-based investment strategies are likely false. Whoa, hold on. Likely false? That's a huge claim. Are we talking about the standard models that practically every fund is built on? You're telling me they're just wrong?
That is exactly what he's arguing. And today, we're going to unpack why. We'll start with the core reason your model might fail, then dive into the traps hiding in your data, the dangerous assumptions we make about causality, and the illusion of statistical significance. And then, we'll wrap up with your new, much more powerful ML toolkit. All right, let's dive right in. Section 1, why your model might fail. And at its heart, the problem is a fundamental mismatch between the tools we've inherited and the markets we're trying to analyze today. I mean, this slide just lays it all out. On one side, you've got classical econometrics. It expects the world to be neat, linear, and predictable. But then look at what modern finance actually is. It's chaotic, nonlinear, driven by messy things like news articles and social media sentiment with thousands of factors all interacting. It's like trying to measure a jagged coastline with a simple wooden ruler. The tool is just completely wrong for the job. So what happens when you use that wrong tool? Well, you fall into some pretty nasty traps, which brings us right to Section 2, the data and correlation traps. This is where the numbers themselves can start to deceive you. Okay, I get that finance is messy, but correlation, that's just math, right? It's a number that tells you how two things move together. How can something that straightforward be a trap? Can a correlation that looks perfect actually be hiding the real story? Oh, it absolutely can, and this is the perfect example of why. Look at the left. You've got a perfect straight line. The correlation metric is 0.9999. It nails it. Now look at the V-shape on the right. There's clearly a perfect predictable relationship there, right? But because it isn't a straight line, the correlation score is basically 0. A traditional model would be completely blind to this powerful pattern. It would just see random noise. And it gets even worse when you throw in outliers. You know those crazy market days? See those red dots? On the left, a standard regression model sees data with just 5% of these outliers, and it produces a massive 34% error. It's literally telling you to buy when you should sell. But on the right, a more modern algorithm like Ransack is designed to spot and ignore those outliers. The result? It's almost perfectly accurate with the exact same data. Okay, this is honestly scary. In a volatile market, these hidden problems could totally wreck a model. How can I actually check for this in my own data? Can you show me the Python code for this? For sure. A really common problem is called multicollinearity. It's a fancy word, but it just means your predictive features are secretly moving together, which makes your model super unstable. This little Python snippet here is your best friend. It calculates something called the variance inflation factor, or VIF. You just feed it your features, and the rule of thumb is simple. If any feature has a VIF score over 5, that's a huge red flag that your model is probably unreliable.
So, we've seen how the raw data itself can fool you. But let's take it a step higher and talk about the models we build on top of that data. Welcome to Section 3, the modeling and causality traps. This is all about seeing connections that just aren't really there.
And this cartoon just says it all, doesn't it? Everybody who went to the moon has eaten chicken. The conclusion? Chicken makes you go to the moon. It's absurd, but we do this in finance all the time. We confuse correlation with causation. And a huge problem is that many econometric textbooks don't really teach us how to properly separate the two.
Wait, so let me get this straight. With the old methods, I'm supposed to guess not only which factors are predictive, but I also have to guess the exact mathematical formula that connects them before I even start? That feels impossible. It pretty much is. And that right there is the magic of machine learning. It completely flips the script. You just give it the potential ingredients, the predictive features, and the algorithm learns the complex recipe, all the hidden connections and interactions, all by itself, straight from the data.
And you don't have to take my word for it. Look at this. On the left, a standard linear regression gets the right ingredients, but it completely misses a hidden interaction between them. The result? A useless mess of predictions. Now, on the right, a random forest model gets the exact same data. It finds that hidden interaction and spits out a nearly perfect prediction, a correlation of 0.98. The difference is just night and day.
Okay, let's move on to section 4. And honestly, this might be the most subtle and most dangerous trap of them all. We're talking about the deception of significance. It's all about how our hunt for statistical proof can actually fool us, especially when we're backtesting.
But p-values are everything, right? I hear it all the time. Statistically significant, p less than 0.05. Isn't that like the gold standard for proving a strategy works? You know, that's what we were all taught, but it's a deeply flawed metric for finance. Get this, at that so-called gold standard 5% significance level, research shows that a staggering 86% of financial discoveries can still be completely false. P-values only care about how well you fit the data you already have, not how well you'll predict the future. And this faulty logic, it's the very foundation of the entire factor zoo, value, momentum, all of them, which puts decades of financial research on very shaky ground.
And that brings us to what Professor López de Prado calls, well, he calls it the most important plot in finance, and you're about to see exactly why.
Here it is, and here's why it's so important. This plot shows that the more strategies you backtest, the higher the Sharpe ratio you are going to find by pure, dumb luck. Look at the numbers. If you test just 1,000 completely random, useless strategies, you are statistically expected to find one that looks like genius, with a Sharpe ratio over 3. This is the definition of backtest overfitting. You didn't discover a brilliant strategy, you just tortured the data until it confessed.
Okay, so we've spent a lot of time talking about the problems, the traps, and the pitfalls. It's probably feeling a little bleak. So let's pivot and talk about solutions. Welcome to our final section, your new ML toolkit. This is all about moving from those flawed old tools to methods that are actually robust.
And this table really sums up the whole mindset shift. Look at the old way versus the new way. The goal used to be in-sample fit. Now it's out-of-sample prediction. We're swapping out flimsy p-values for solid feature importance metrics. And we're ditching simple R-squared for rigorous cross-validation. It's a whole new ballgame. So let's get really practical here. Here are 3 things you can do right now to debug your process. First, test your data for stationarity. This stops you from finding those silly, fake relationships, like thinking ice cream sales cause shark attacks just because they both go up in the summer. Second, use that VIF code we just showed you to fix multicollinearity and make your model stable. And third, please use cross-validation. It's the only real way to know how your strategy will hold up in the wild, not just in your spreadsheet.
So it really all comes down to this. Are you going to keep using a playbook that's designed to explain the past? Or are you ready to start building strategies that can actually work in the real world?
Wow, that was a lot. It really feels like a complete reset on how I should even think about building a strategy. I've got so many things to go back and test now, and we're really just scratching the surface. Make sure you subscribe because we've got a lot more to cover in our Cornell Breakdown series. We'll see you in the next one.